Supiksha. I am going to explain about the chemistry and the physics of the muscles. The biochemistry of the muscle is based on the enzymic activity of myosin, its ability to catalyze the hydrolytic cleavage of ATP. M plus ATP by reverse of M ATP. M is divided into ADP and P, where M plus ADP plus P. The reaction strongly depends on ionic medium, on the presence of divalent cation. pH is equals to 7.4. For the reaction to proceed in vitro, it is necessary that calcium being present. It is optimal with concentration of this ion being equal to the concentration of ATP. The Mg ion inhibit the ATP's activities of the myosin in vitro. In muscles, myosin function upon interaction with the actin has been appointed through HMM bridge in actomyosin complex. Thus, the ATP's activities to be exhibited in vivo, both calcium and magnesium are required. The activation of sterile muscles occurs as a result of the transmission of the nerve impulse to it. The muscle's contraction can also be initiated by artificial electrical pulse. The action of the impulse leads to an increase in concentration of the calcium interact with the fibril. Each fibril is enwrapped by a complex system with fibril of longitudinal and transverse thin tubes called as sarcoplasmic reticulum. It is proved that it aids to an calcium atom. The transmission of nerve impulse causes the transition of calcium from reticulum into gel-like cytoplasm which surround that protein. The concentration of the free calcium is released muscles is very low, like 10 to the power of minus 7 to 10 to the power of minus 8. ADP plus phosphocreatine, where creatine is ATP plus creatine. ATP split upon contraction of the muscles. The fluorodinitrobenzene inhibit creatine kinase and stop the Lohmann's reaction. This is a Lohmann's reaction. It doesn't affect contraction. ATP split during single contraction and tetanus contraction. The reverse reaction of the phosphocreatine blocked by a idocreatine from phosphocreatine to creatine. The relaxation of the muscle, its initial stage, is determined by expulsion of calcium from sarcoplasm into reticulum. The relaxation of the absence of calcium ion troponin complex with the tropomyosin inhibit the interaction of actin with myosin. The calcium enters the sarcoplasmic blind to the tropin and suppress its inhibitors. Hence, calcium plays a role of the depressor and switch the thin filament over the inactive to the active bites. Isotonic contraction means that the muscle is allowed to shorten against the constant load. In this case, the muscle performs work lifting the load. That experimental procedure of corresponding measurement that developed in the classical work of Heels and the later is improved. The muscle's M is attached to one of the end of it. The other end M is tied to the rigid support. So we can see this is a diagram with the schematic setup for the steadying muscle contraction. So you can see the diagram in this. So after this, when isotonic twitches are to be steadied, the muscle is loaded at the position P, transferred T at a position A. Isotonic shortening is determined by movement of other and never recorded by the mean of the movement photocells PC. The stop is controlled by an electromagnetic EM is used to hold up all the contraction muscles at any desired extent. The experiment with frog cirrhosis muscle shows that the after excitation of the isotonic contraction, there occur a series change determined by release of calcium from sarcoplasmic reticulum. Here the tension being to increase, reaching its maximum after 170 meter per second. Hills has empirically established the basic characteristic equation in mechanism of muscles contraction. It relates the steady velocity force P and has a hyperbolic form where P plus A into V is equals to B into P naught plus V, where P naught is the maximum isotonic tension developed by the muscles. At P is equals to 0, the velocity of the shortening is maximum V, where V max is equals to B P naught by A, where P is equals to P naught, we have V is equals to 0, and where P is greater than P naught, the muscle is no more shortened, it is stretched. This stretching does not obey the equation. So the constant B has a increases rapidly with temperature on heating by 10 degree with nearly 0 degree. The constant B is double. Hill's equation is valid only at the constant velocity of shortening. At the same time, the scope is application is limited by the muscle length. The maximal tension P naught depends on the length of the sarcomere. P naught is maximal corresponds to certain platelet region. The quantity P naught depends with a little on the temperature, increasing only slightly with the increase of the temperature. This refers to the constant A proportional to the P naught. The work done by the muscle contraction is equals to the Hill's equation, where W is equals to PVT is equals to BPT, B naught minus BP by P plus A. The function WP is bell-shaped. W turns to 0 at P is equals to P naught and P is equals to 0. According to Slide's filament theory, the tension developed by muscle is entirely determined by the filament, actin, myosin, and Z disc. All these elements are not quite rigid. The terminal sarcomeres of muscle fibers are attached to the connective tissues of the tendons, and there is observed the total contribution of the elastic and plastic deformation does not exceed like 3% of the tension. The maximal tension of the P naught of the frog's muscles is equals to 30 Newton per meter square to 3 into 10 to the power minus 10 Newton for the thin filaments. Each single element contains one myosin molecule, and each closing and opening cycle ATP energy used is 50%. We obtain the following characteristics of the single compound, that is 3 into 10 to the power minus 12 Newton distance and 10 to the power minus 6 energy and 6 into 10 to the power minus 20 joule and time 1 meter per second. At early stage of the contraction process, before the tension has developed or before shortening has occurred, this heat is associated with the entire entry of the calcium ion into the sarcoplasm with their interaction with actomyosin system. If the muscle is shortened, the heat Q is liberated faster than the isomeric contraction. The total energy of the energy during the contraction process is equals to delta E is equals to Q A plus QC plus W. In the Hill's experiment, the muscles has constantly simultaneous to the isomeric contraction. The rate of the energy liberated in the form of the heat and the work is equals to E is equals to the W plus alpha V plus M is equals to alpha P plus V into M plus M, where M is the rate of the liberation and alpha is the rate of the liberation of the extra heat. If it has been found that if the muscle is capable of shortening, the total energy liberated the muscle during the single stitches is greater than isomeric contraction. This is the Fenton's effect when U is equals to W by E is equals to W by W plus Q. If the contraction of the nu reaches 45% in the frog and the 75% in the turtle, so free energy remains constant. So delta G is equals to 0. So this is all about the chemistry and the physics of the muscles. Thank you.